So this video is going to talk about parabolas, and more from a geometry standpoint. The way we define parabolas in this unit is it's the set of all points on a plane, on a piece of paper, that's the same distance from a certain line and a fixed point. We call the line of directrix and the point of focus. So here's a picture of a parabola, and it's kind of been placed in a model that would fit our definition. So we have our fixed point right here, we call that the focus. Here is our line that we call the directrix. Notice that from here up it's a distance of p, and from here down it's also a distance of p. So this coordinate for that point is 0, p, and the equation of that line, a horizontal line, is y equals negative p. And so when I talk about the distance being equal, I can pick any point. They just happen to pick this point right here, and because it's on this equation that we're dealing with, they're just going to call this point xy, make it really use some unknowns or some variables there. But the distance from this point to the focus has to be the same as the distance from this point to the line. And it can be kind of hard to draw the picture just from by hand, but with some technology it makes it a lot easier. But remember, the distance from a point to a line, it has to be at a perpendicular direction or at a right angle. So that's another thing to kind of keep in mind with our picture, that if I picked a point up here, this would be the distance to the line, and then from here over, that would have to be the same distance. So from this, how do we come up with a formula? And so I want you to think about maybe the distance formula that you learned in geometry. So we know that the distance from P to F has to be the same as the distance from P to D. And we have coordinates for all of these points. We know that this has to be 0, p, because it's on the y-axis, so the x value is 0, it goes up an amount of p. This would have to be however far to the right we went, which is x, because it lines up with this point right there. And the y value has to be negative p, because remember, it went down by p right on the y-axis here. So we can come up with the coordinates for these 2 points. This is just going to be basic x, y. So to talk about the coordinates, or the distance from f to p, or from p to f, our distance formula would be the square root of, and we have to go our x value subtracted, so x minus 0 being squared, so that's my x value here and my x value there. And then I would add to that the y values being subtracted, so that'd be y minus p being squared. So that was the distance from p to f. Now we want to do the distance from p to d. So the same sort of idea. Let's see if I can squeeze it in here. So I'd have x minus x plus y minus a negative p, which is really y plus p, and that has to be squared. Okay, so our job is to try to simplify this and make it into an easier statement to work with, but this is where the definition starts from, saying it's got to be an equal distance and then setting up an algebra formula that would meet that. So I'm going to write a few things down here, and it will go a little bit faster. So one of the first things I can do here is I can just simply square each side. If I square this, the square root goes away. I'm left with what's underneath. Square this, left with what's underneath. I just have to simplify that. So x minus 0 is just x, and then I square it. I get x squared for this piece. If I were to FOIL the next piece together, y minus p times y minus p, I would end up with a y squared minus 2, we'll just say 2py plus p squared. So that's everything on the left side. And then on the right side, x minus x is just 0. If I square that, I still have 0, so that doesn't matter. So I just need to worry about foiling the second part together. And when I do that, I'm going to get y squared plus 2py plus p squared. And a few things are going to cancel off there. I have a y squared on the left and on the right, p squared on the left and on the right. And so the only other thing I'm going to change then is I'm just going to combine the two py's. So I'm going to add 2py to this side, so that goes away. If I add 2py to that side, it's going to, in the end, get me x squared equals 4py. And I know it seems a little confusing, but that's actually the formula that we want to use for a parabola that opens up or opens down. So let's just kind of think about what this means. X squared kind of makes sense. You know, it opens up. That's typically when we graph something, it would be x squared for a parabola. But what does this p mean? P means the distance from here to here. So if we can figure that out, I can simply plug that value in, multiply it by 4, and I'm going to have y times that number equals x squared. A lot of times that's what we'll use. And the other thing is, what does 4p stand for? 4p is actually the distance, in this case horizontally, from the focus from the sides of the parabola there. So that distance will always be 4p, and this distance will be p, and sometimes that's useful. The 4p is actually the focal width, is what they call that. Okay, so this slide just shows a bunch of formulas. I'm not going to ask you to memorize this at all. We're going to base this more on our picture. But we just kind of learned all of this stuff right here. We learned the basic formula and then also some of those different values there. So we can definitely talk about that in class if we need to. We'll go through an example that deals with something like this where it opens to the left or to the right. Just notice that the x and the y stuff switch around in the formula. That's basically the big thing. So let's quickly look at two examples. Okay, this example says find the equation in standard form for the parabola if the directrix is the line y equals 6 and the focus is the point 0, negative 6. So I always like to draw a picture for these things, and I'm definitely not saying that my handwriting is going to be fantastic for this, but here's our coordinate plane. We have a directrix for y equals 6. Let's just say that is right there. And we know the focus is the point 0, negative 6, so something down there. So the focus, here's the directrix. That means my parabola has to start right in between them. So it's actually going to start at the origin, and most of what we're learning in this video, that will be the case. So my parabola has to surround the focus, so I'd have something kind of like that. So because it opens up and down, I know it has to follow the form of x squared equals 4py. That's the formula we came up with. And for this, all we really need to do is measure the distance from, let's see if I can come up with a, I don't know if I'm going to come up with a different color here. I just need to find the distance right there from the base of that parabola, from the vertex, all the way to the focus. And so if it started at 0, 0, it's going to go to 0, negative 6. The distance is 6, and because it's opening down, I need to say that p would equal negative 6. Okay, so my formula for this would equal x squared equals 4 times a negative 6 times y, or x squared equals negative 24y. Okay, example 2, excuse me, will be kind of the opposite. Now I'm going to give you the equation, and we're going to work backwards to figure out the formula for the vertex, the focus. We could even say the directrix for this. So in this case, the formula was y squared equals 20 times x, and we always know that it's going to start out as 4 times a number, so 4 times 5 in this case, times x. And then you also notice that it's y squared this time. So y squared, that means it's going to open to the right or to the left. And in this case, because p has to equal 5, p is positive, it's going to open to the right. So again, here's my coordinate plane. This time, it's going to open to the right, so something kind of like this. And because p is 5, that means I have to go 5 units to the right to find my focus. And I'm going to go 5 units to the left to find my directrix. And so my coordinates for this then would have to be, again, this distance right here has to be 5. So my coordinates are going to be for the vertex, in this case it's going to be 0, 0. My focus is going to be 5, 0. And my directrix, that's a line, it's a vertical line this time, so my directrix would be the line x equals negative 5. Okay, so jot down any questions you might have. Let's start with that. Jot down any questions a second. And now what I'd like you to do is to go to the back of your note packet, look at problems 1 and 2, and give them a try yourself. They should follow the same format as what you just did here. And in about 10 seconds, I will go to the next slide. I'm just going to show my work. I'm not going to talk at all. It'll just be a slide showing all my work. And I'd like you to check both of those questions. And if you got them right, great. If not, you should have some questions to ask in class.